In order to start refining what the actors in our current scene are doing, we'll need to use a post-process volume to set a few different settings up. We'll also use it to set the scene exposure and to take a look at some real-world photometrics. Let's create a post-process volume by just searching in the Place Actors tab here, Post-Process, and I'll just drag this into the scene. And you see the bounding box. We can either scale that to be our scene, or I'm actually just going to zero this out and put it below our level and just search for bound and click right here under infinite extent. So now it's just an infinitely bound post process. Let's stay organized and throw this in a folder called volumes. And we'll have a different post process volume for each lighting look. So let's make sure that this one has a unique name. There we go. All right, so we've got this volume now and we can start to play with a few things. Let's search for ray to bring up the ray tracing settings. The first thing we'll fix here is this reflection of the floor, which isn't quite as accurate as I'd like. So we will make sure that this type is set to ray tracing and this max roughness is set to 1. So that's important because before that, at a value of 0.6, any material with a roughness of 0.6 or higher is just going back to screen space. And that's a useful trick if you're worried about performance in a game, for example. But in our situation, we just want to get full ray trace reflections. So we'll do that. And that already looks a lot better. And our scene is a little dark. So let's bring the exposure up. And I like to just search for EXP here. And we'll click metering mode, manual, because we're setting the exposure and we're not going to do any auto exposure stuff. And exposure compensation, let's bring this all the way up to 12 just to start, or maybe even 13. Okay, so now we can kind of see what we're doing. We'll get back to those exposure settings in a second, but first I'd like to bring in a color calibrator tool. This is kind of a useful static mesh you'll find in the content browser here. Over on the left, if we bring up that sources panel, let's just search for color calibrator and bring this static mesh into the scene. I'll just drag it up like that. I'm going to clear that search and then click on content so that our content browser just goes back to the default. All right, so we've got this useful little mesh here with some reflective materials and a color chart. The first thing you'll notice is that our full mirror ball here is not doing what we want in terms of ray tracing. It's giving us a fully uniformly lit situation here. And that's from the skylight. If we turn the skylight down to 0, we're back to nothing there. So we know that's kind of what we have to play with. So let's use a few different console commands to fix this. There's 3 that we're going to use today. I've got them here on a slide for you, just in case you want to take a look. But here's what they're going to do. The first is this r.raytracing.reflections.hybrid, and we'll set that to 1 so that it's on. And that's because Unreal Engine is a hybrid lighting engine. And by enabling that, we're kind of using the best of both worlds here. We'll also hit the tilde key again and use the reflection captures command here. I'll set this to 1. And that did a little something, but actually in order to make use of this, we need to bring in a reflection capture into the scene. So let's search for that in the Place Actors box. And I'll just drag a sphere reflection capture and drag this around. And I'll put that in the volumes folder too. If I turn this off and on, you'll see a big difference, especially in this shiny silver material. And so that last console command we used is actually using the sphere reflection capture as a additional reflection bounce. So that's just kind of a neat trick. And then lastly, if we go back to our mirror ball, I'm still not super happy with the fact that it's just completely lit. So, if we didn't have a mirror ball, you wouldn't know, but just in case, it's always worth kind of checking different materials out. So here's our last console command to enter, and this is a doozy, but it's the reflections ray trace skylight contribution command, and we'll set that to 1. And boom, there we go. Right off the bat, a much better place to be in. So that just turns off this skylight contribution in these reflections like that. So we're still getting some light in these reflections, but it's a lot more true to what the actual room is outside of that mirror ball. So I'm just going to leave that as is. All right, so the last thing we'll do here is to just take a look at those exposure settings in a little more detail and also explore the real-world photometrics that Unreal uses, both through the post-process volume, which, by the way, I'll just start calling PPV, and a CineCamera actor. Let's actually make a CineCamera actor level before we do anything else. I'll just create new up there, empty level, and call it camera. Next up, place actors. I've already searched for Cine, so I can just click and drag that in. And I'll just hit G so we can see this here. And you know what? It's easier to fly this around. I'll just click Perspective, CineCamera Actor, and I can just place this right here. Okay, so if I exit that and then just hit this little pin, it'll just stay glued in the viewport. The first thing I wanted to bring up is that the exposures are slightly different, and that's because they currently have different settings. So it's as simple as making sure the settings are in sync between the PPV and the CineCamera. The easiest way to go through these, I find, is to just use the search detail panel here. So I'll type EXP, and on the PPV, we had manual and 13. So for the CineCamera, we'll do the same. The CineCamera also has an aperture by default, so if we just search for that, we'll see that it's currently set to an f2.8, and the PPV is actually not set, so we'll click that and type 2.8 as well. In order for the photometrics to work, we'll also set the shutter speed and the ISO for the camera, and therefore the PPV. So I'll just start with ISO, and I'll use 800 because that's a common ISO for cinema cameras. And back in the PPV, we'll make sure that's also 800. All right, I can search for shutter speed finally, and we'll set that to 48. And same in the post-process. Okay, so they're in sync. We're obviously a little overexposed. So let's go back to the exposure compensation. And I'll bring this down to 9. And same with the CineCamera actor. Okay, so we're at a good point at which everything's in sync and we've got settings set for everything we need. The big secret behind the real-world photometrics in Unreal Engine isn't actually a big secret. You just need to use real-world values for your lights. And if we click on our directional light, you'll see that it was defaulted to 10 lux, but if you Google what sunlight really is in terms of lux, it's actually over 100,000. Wikipedia told me 111,000. So if we do that, obviously a nuclear explosion here, but let's just click on the PPV and search EXP, and we'll just bring that exposure compensation to -6. And all right, let's also do the CineCamera. Great. So what changed here? Well, our sunlight is looking good and the sky adjusts accordingly because those are all linked, but our skylight did not recapture. And that's because we need to do it ourselves, remember? So I'll just click on the skylight, search for recapture, and there we go. We've got that back. And just like that, we are using real-world photometrics. So in the CineCamera, with the exposure compensation, what this setting represents is a neutral density filter when you're in the negative here. For those of you who are used to using real-world cameras or even just photographers, that's what this value is doing. So if I do -5, maybe -4 to bring everything up, and I'll do the same in the post-process. Oops, there we go. We're getting back to where we were before, but just with real-world values, where our aperture is actually set to a 2.8, and we're just throwing a neutral density filter that brings the exposure down by 4 stops. Now, before we move forward, I am going to just reset all this back to the defaults because in this course, I don't really need to use the real world values. I just wanted to show that you can. It's that simple. But we'll just reset this back to 10. We'll recapture the skylight. And now all we need to do is just change that exposure back to, I think 13 was the number. Oh, you know what? It was 9. There we go. So same here, 9. And there we are, back to where we were. All right, so we've made progress now towards achieving our cinematic photorealism goal. You can arguably get really far with the tools we've looked at, but there's still quite a bit to do in terms of both lighting and settings, but there's just a lot to get through here. So we'll take it one step at a time. Next up, though, will be kind of the final process for getting this sunlight look to a really good spot.